Life in the deep sea, a journey into darkness and discovery. When we think about the most mysterious and extreme places on Earth, our minds often wander to the icy peaks of the Himalayas or the scorching heat of deserts like the Sahara. Yet beneath the waves of our planet's oceans lies a realm far more alien, inhospitable, and unknown: the deep sea. This dark, pressurized world begins just a few hundred meters below the ocean surface and stretches down to the abyssal plains and trenches thousands of meters beneath. It is a place so remote and challenging to explore that we know more about the surface of Mars than we do about the very bottom of our own oceans. And yet, against all odds, life exists there. Not just sparse or simple life, but ecosystems full of strange, beautiful, and resilient creatures. In this presentation, we'll dive into this hidden world and explore how life manages to thrive in one of the harshest environments on Earth. 1. What is the deep sea? An alien world beneath our oceans. The deep sea is typically defined as any part of the ocean below 200 meters, 656 feet, where sunlight starts to fade significantly. At around 1,000 meters, 3,280 feet, sunlight disappears entirely, plunging the ocean into complete darkness, the so-called midnight zone. But that's just the beginning. As you descend deeper, pressure increases dramatically. At the bottom of the Mariana Trench, nearly 11,000 meters down, the pressure is over 1,000 times that at sea level, enough to crush a nuclear submarine. The temperature drops to near freezing, typically between 2 to 4 degrees Celsius, 35 to 39 degrees Fahrenheit, and the water becomes devoid of most nutrients. No plants grow in these regions because photosynthesis is impossible without sunlight. Food is scarce, and the conditions are often compared to outer space, except wetter and darker. Despite these extreme conditions, the deep sea is not lifeless. It is one of Earth's largest and most diverse ecosystems, covering more than half of the ocean's volume. The deep sea is divided into several zones: bathypelagic zone, 1,000 to 4,000 meters, the midnight zone, completely dark; abyssopelagic zone, 4,000 to 6,000 meters, near freezing, crushing pressure; hadalpelagic zone, 6,000 to 11,000 meters, found in deep ocean trenches like the Mariana. In these zones, nature has written a different set of rules, and life has followed suit. 2. Deep sea creatures. Evolution's strangest creations. Imagine a world where light is produced by the animals themselves, and survival depends on being invisible, grotesque, or glowing. This is the deep sea. Let's take a look at some iconic creatures and how they adapt to such a strange world. Anglerfish. Perhaps the most famous deep-sea resident, the anglerfish has a bioluminescent lure growing from its head, which it uses to attract prey in the darkness. Some species exhibit extreme sexual dimorphism, where the male is hundreds of times smaller and fuses permanently with the female. Dragonfish. These predators emit red bioluminescent light, which is invisible to most other deep-sea creatures. This gives them a stealthy advantage when hunting in the dark. Giant squid. Reaching lengths of up to 13 meters, the giant squid remains largely a mystery. It has massive eyes the size of basketballs, adapted to spot faint light or distant movement in the darkness. Jellyfish and comb jellies. Many deep-sea jellies glow in beautiful colors, red, green, blue, due to bioluminescence or iridescence. Some use flashes to confuse predators, while others may use it to attract mates or prey. Giant tube worms, found near hydrothermal vents, these creatures have no mouth, no stomach, and no digestive tract. Instead, they house symbiotic bacteria that convert toxic chemicals into nutrients. Other bizarre adaptations include transparent bodies to avoid detection, slow metabolism to conserve energy, enormous teeth, and expandable stomachs to swallow large prey when food is scarce. Every adaptation tells a story of struggle, survival, and incredible innovation by evolution in the absence of light. 3. Hydrothermal vents, a new foundation for life. One of the most revolutionary discoveries in biology came not from land or the skies, but from the depths of the ocean. Hydrothermal vents. Discovered in 1977 near the Galapagos Rift, hydrothermal vents are fissures in the Earth's crust where seawater seeps in, is superheated by magma, and bursts back out, rich in minerals and chemicals like hydrogen sulfide. Despite temperatures reaching 400 degrees Celsius, 752 degrees Fahrenheit, entire ecosystems thrive here. How is this possible? The answer is chemosynthesis, a process where